is. Yeah, so we're saying limits. When we say we have a limit to a function, a limit as x approaches a of, let's say, function f of x, we write it as the lim. We write it as the lim as x approaches a of f of x. And we're saying this is just going to be the same as you placing a in the function, provided the following conditions have been satisfied. To be satisfied, a must be part of the domain of the function that you are dealing with. That's the first property that should be satisfied. Then b, we just say that the function is going to have what we call the left hand side limit. The left limit and the right limit have to be the same. Yeah, so I'll explain this using your question 1 from your tutorial sheet 8. The last 3 questions. Yeah, so look at this. Then the last statement is that f of x has to be defined. So f of x should be defined at x is equal to a. That's what we expect. That's what we have. So I'll go straight to your tutorial sheet. Look at this, your tutorial sheet here. I'll use them as examples. Look at the first question. The first question is saying, in each case below, evaluate the limit if it exists. We need to check first if it exists. And for you to do that, you need to make sure that the number you're approaching satisfies the previous 3 properties that we're from discussing. The number that we're approaching has to be part of the domain. And this is a quadratic that you have here. So we'll start with question 1. We'll do all the questions here. The function we're approaching is simply 2. So we're saying, what is the limit? So let's call them examples. You understand best by doing practice. Yeah, so we're saying the limit as x approaches 2 of x squared minus 8x is it plus 12. That's our question, right? Let me bring this guy close to my document. Okay. Yeah, this is what we're having. It's a 3, or it's a 3 at the end. It's a 3, it's a positive 3. This is a plus 3. So this is what we have. These are the conditions that should be satisfied, and this is our question here. So look at this problem here. We're going to just write it as the limit as x approaches 2. We're going to split them. Each piece has to be represented separately. So as the limit approaches 2 of 8x, and also the limit as x approaches 2 of 3. So if we're approaching a function which is x squared is defined everywhere because it's a quadratic, it's a parabola, right? It allows 2, it's defined at 2. So we'll simply put the 2 there, squared minus, put the 2 there. Then the limit of a constant is always going to be a constant because there's nowhere where we can replace x by 2. So this is just going to give us a 4 minus 16 and then plus a 3. This gives us a 7 minus 16. This should give us what? Is it negative 9? Is to put the number you're approaching in the function. Is it giving you something that makes sense? Is it possible to put 2 in this function and get an actual integer? Yes, it is. So no wonder we're just replacing directly. So this gives us our answer. So the limit is negative 9. That's what you get. Look at the next question. The next question here is this guy.
I have a question, sir.
Yes, Isaac.
So there's no difference between f of x and the lim?
There's just a minor difference. The minor difference is that for lim, we have to check the properties. These 3 conditions have to be satisfied. For f of x, we didn't have properties. We just replaced the expression. We just put our number there, right? But here, we have to be certain that the number we're approaching is part of the domain and the function is defined at that particular point. Yeah, so can you just stay with me a little bit close? You'll see how we are going to handle G, H, and I. Yeah. To answer your question properly, I'll answer it using this. Okay, so look at.
All right, sir.
So look at maybe before we go anywhere, let me just follow the order here. Yeah, so look at your expression that we have here. This is the limit as x approaches -3 of something in a square root. You know, to say square root do not accommodate negative numbers, right? So let's call this to be example 2. Yeah, we're saying the limit as x approaches -2 of the square root of, is it a 13 minus a 4x, if I'm not mistaken, or 13 minus 4x. So we are here, we're going to put the negative in the function. So there's a rule that says this is the same as the lim. You put the lim inside. So there are properties. I'm not going to waste time to teach you the properties here. I'll just teach you how to solve, because you won't even be showing the properties on solving. We just need you to replace and do the right thing, mastering all the cases, the possible cases you can have. So -2 is going to be placed there in there where there's x. So this is just going to be 13 plus 8. Is it? Yeah, so this is going to give me what? This is going to give me, is it a 20? What do we get here? Is it a 21? I'm getting a 21 here. Have I made a mistake anywhere? Okay, so I think I've not made a mistake, because this is going to give us a positive. We have this. So this is the answer that we're getting. We're unable to evaluate it further, right? So that's going to be the answer. It's a proper number. It's a radical number. The root of 21. It's a proper number, right? Yeah, so that's okay. Because if you check to just validate what we've solved, check what's the domain of this. You learned radical functions. What's the domain? So we say this guy has to be greater than or equal to what? 0. That's a domain. Let's see if -2 is part of that domain. Take the 13 this side. Then you're going to have -4 and also -4. Then you say x is what? Less than or equal to 13 over 4. All numbers less than 13 and 4 from here, closed, going down up to -infinity. That's a domain of which -2 is part. So meaning this function is defined at -2. No wonder we're able to find the limit does exist. Because in the question they said, find it if it exists, meaning there are cases, there are questions here where the limit will not exist. That's what they were trying to emphasize. Yeah, so look at the next one. I'll do the next one here. See, they have given us the limit as x approaches 2 of x to the power 3 minus 8 over x minus 2. So this should answer your question here, Isaac. This should guide us in trying to satisfy what I was saying. So question 3, the limit as x approaches 2 of x to the power 3 minus 8 over x minus 2. So of course you're going to try first, right? You're going to try by putting 2 wherever there's x. If you try that, you'll notice that you get a 0 here on top. Then you get 2. We're putting 2, sorry. We're putting 2, this 2 wherever there's x. So here you're going to get something like this. Look at what you're getting. A 0 over 0, right? So 0 over 0 is undefined. We don't know what that is. The only thing that we know is 0 over a number. We don't know what a number over 0 is. We also don't know what 0 over 0 or n over 0 is. So we cannot have something like this. It will be undefined. So instead of writing something undefined, we're going to simplify this expression on top to be something that accommodates 2. We're going to redefine it so that it can accommodate 2. In short, I'm just going to divide the numerator by the denominator. So I'm going to say, I'm going to use synthetic. So hope everyone is okay. If I write this as x to the power 3 plus 0x squared plus 0x, then minus 8, then over x minus 2. So x minus 2 is the factor, meaning x is equal to 2 is the number I'm going to use in my synthetic division. I'll put my 2 there. Get the coefficients. There's a 1, there's a 0, there's a 0, there's a negative 8. Then take the 1 down. This is going to be 1. 2 times 1, that's simply 2. Hope you remember synthetic. 2 times 2, that's a 4. 2 times 4, that's simply giving us 8. Add this, they give you a 0. So it's like we are saying the polynomial that we had is equivalent to x minus 2, x squared plus 2x plus 4. It's like I give you 20, guys, 20 over 4. So 20 is the same as 4 times 5. Okay, I write something like this. I just want the 4 and the 4 to cancel. So it's the same even here. X minus 2 on top. I write this quotient, which is x squared plus 2x, then plus 5. Then down I'm having x minus 2. The whole idea here was for us to be able to cancel the part which is making both the numerator and the denominator to be 0, which is this part. That's the reason why we had to factorize the numerator by the denominator, so that what we are going to get now is the limit as x approaches 2 of x squared plus 2x, then plus 5, or plus 4, I mean, sorry, this is 4. Yeah, so this here is a 4. Yeah, so this is a 4. This is now a quadratic, which is just exactly like question 1, which accommodates the the number 2, because the whole quadratic will have all real numbers as the domain. So now we can just replace wherever there is x, put your 2, and if we do that, you're simply going to get a 2 squared, a 2 and a 2, then plus a 4. This just gives us our 12. Daniel, Madali. So guys, anyone who is lost here, can I get some feedback? Is everyone okay with this part?
Yes, sir, it's okay for me.
Okay, that's good. So this is what you do whenever you have a quadratic or a polynomial on the numerator, or even in the denominator. Like this question here, D, they're just telling us to say it can also happen with regards to the denominator. You just reduce the guy which is big. In this case, the denominator is the one that's big, and the numerator is having x minus 3. So we're going to divide the denominator by x minus 3 the same way again. And if we do that, we do the division. We're simply saying x minus 3. I'm using long division now. I just want to give you a variety to help you remember, revise everything that you learned, either long division or synthetic. So x into x cubed, that's x squared. That's going to be x cubed, then minus 3x squared. Then here, we're going to find the difference. This is 3x squared. Bring the 0 down. 3x into that, that's going to be 3x. And we are going to multiply everything by 3x. That's going to be minus 9x. The difference here will be 9x. Then bring down the negative 27. Here, again, this is going to give us what? A 3. Suppose, am I doing the right thing here, guys? This is supposed to be what? The answer on top, yes, okay, yeah. This has to be 9, yes. Yeah, so yes, it has to give us this minus, because these guys have to be the same, right? Yeah, so we have this minus, this gives us a 0. So already you are seeing that the guy here in our question is the limit as x approaches 3 of x minus 3, and we have x3 minus 27. So the guy down can be rewritten x approaches 3, there's x minus 3 there, then down we're just having x minus 3 and x squared plus 3x, then plus 9, so that this part and this part can cancel, leaving us with a 1. and this is going to be the limit as x approaches 3 of 1 over x squared plus 3x then plus 9. Then when you reach at this point, there is nothing wrong with you replacing where there's x you put a 3, because the function will accommodate, the down part here is a quadratic which accommodates everything. So put 3 there, that will be 3 squared plus 3 and a 3, then plus a 9. This will just give you 1 over 27. Right here you get your limit as you approach what? As you approach 3. Is everyone okay with this, guys? So the next one here, if there's a radical expression attached to a number, which is how we do E, is how you will do F as well. So I'll only do one of these. I'll do this one and I'll leave this one here as your task to send it to me just after the class is done. So we'll rationalize the denominator. So we'll multiply both the numerator and the denominator, because if you put 1 directly there, the whole thing becomes 0. The down part is 0, the top part also becomes 0, and we don't want that to happen. So this is question, this is number 5 now. This is example 5. The limit as x approaches 1, x minus 1 on the numerator, then down you have 2 minus, there's 5 minus x. So I was saying we rationalize this using the denominator. So I'll multiply the top part by x plus root of 5 minus x, the down part as well with 5 plus root of 5 minus x. So I'm multiplying, by the way. This will be limit as x approaches 1. This is going to be, don't multiply the top part, no need. Leave it to be the way it is. The down part is the problem. So the down part, you're going to multiply the first term and the first term there. This gives you a 4. Negative and positive, that's a negative. Multiply the second term and the second term. This gives you 5 minus x. I've just done a shortcut here, guys, because I know to say there's no need of multiplying everything by everything, because the middle part is going to cancel. So if you're multiplying anything with regards to its own conjugate like this, just multiply the first and the first and the last term, so it will give you this. That's what I basically did. Yeah, so here I'm having limit as x approaches 1. The guy on top, don't tamper with it, leave it the way it is, 5 minus x. Then down here I'm having 4 minus 5 then plus x, because the negative is affecting everything. This is going to be a negative 1, so it will be negative 1 plus x, which is the same as what? So permit me to change this and write it as x minus 1, so I just don't waste space. So you're able to see that this part and this part will cancel, leaving us with the limit as x approaches 1 of 2 root of 5 minus x. 2 plus 5 minus 1, this is a 4 this side. So root of 4, that's a 2. So the answer here is just 4. That's our outcome. So the limit as we approach 1 to this expression, the answer is simply going to be to be 4. That's what we have. Any questions, guys, here? Okay, if there are no questions, we proceed to the next one. The next one is where we are given rational functions. So this is going to be a full stop to limits in particular, trying to check if the limit exists, because here we're going to be exhausted out of options, I mean, in terms of trying to simplify them, because how else are we going to come up with something that simplifies the numerator and the denominator when they have nothing in common, and the number we're approaching gives us this expression to be having a denominator that is equal to 0, because look at what you're having there. There is 1 approaching the limit as x approaches negative 1, 1 over 1 plus x. there's nothing that can be done in this case for us to simplify this. You cannot conjugate, you cannot do anything. Remember what you are doing under rational functions, right? If you are trying to get the domain, what's the domain here, guys? Or rather, let me just ask about the vertical asymptote. What's the vertical asymptote here, guys? Anyone? -1. We always solve the down part. So solve this part, the down part, the denominator all the time. So 1 plus x should be equal to 0, meaning x is equal to -1. You have this. So this is a number that we should never cross, right? So we have -1 somewhere there. So we show it. I just want you to see something here. So we show it. That's what you have. Then we try to get our x-intercept. Is there any point where we're going to touch the x-axis? Let's check. If you put where there's, treat this like a function, treat it to be like this, 1 plus x. So if you put 0 equal to y, there is no number of x you're going to get, because you're going to get 0 is equal to 1 over 1 plus x, meaning 0 is equal to 1, which is mathematically wrong, because 0 cannot be equal to 1. Yeah, so we're simply going to say the x-intercept does not exist. We do not touch the x-axis at any particular point. And how about the y-intercept? When x is 0, this is 1, 1 plus 0. This just gives us 1. So meaning we're touching the y-axis at point 1, making the graph to look like this. So the graph is supposed to look like this, and the twin will look like this to be there. Yeah, so if you remember how you are sketching your rational functions, then this will be okay, because the answer here with regards to our limit is that the limit does not exist. So the limit as x approaches -1 from the negative side. Look at what happens if you're coming from this side, right? From the negative. Where does the bus go that comes from negative? It goes down. Look at where it goes. It goes down to -infinity. So as you approach the function from the negative side, you go to the negative side down. Then if you approach the function, approach -1 from the positive side, you simply go to the positive side. It blows up. You're coming from this side. Where does the bus go? It goes up, continuously up, which is to +infinity. Look at what you are having. The left and the right limit are not the same. So this is against the rules. Remember the rules, we say the left and the right have to be the same, right? So this is contradicting what we learned pertaining the conditions for a limit to exist. So you're going to put a conclusion here. You're going to say, since, you're right, since the left limit, meaning x approaching -1 from the negative, is not the same with the limit as x approaches -1 from the positive, the limit does not exist. You write this, limit does not exist, DNE. The sided limits, the left and the right hand side limits do exist, but the overall limit does not what? Does not exist. Is this okay, guys? Anyone who has any questions here? Is this okay? Anyone who is lost here, guys? Okay, so if there are no questions, I'll go to the next one as well, just to solidify this. So there are 3 of them. I'll do the last one as well. Then I'll leave the other one for you as a task. Yeah, so look at the next one. The next one is this guy here, h. So again, we're approaching 2. We cannot replace the down part with 2. So we'll just proceed to check using the method of sketching. So you have to sketch, because I'll say show your working. Yeah, so the limit as x approaches 2 of 4 over 2 minus. So this is, there's a 4, then there's 2 minus x. So the vertical asymptote is when you solve the down part. So this is going to be 2 minus x is equal to 0. This is just -2. X is equal to 2. Yeah, so we're saying we should never touch 2. 2 is right here. So we should never cross 2, right? This is what you have. Then when x is equal to 0, this is the same as 4. Then you have 2 minus 0. This just gives us a 2. So we're touching the y-axis at 2. Meaning if we're touching it at 2, the graph is going to have something that looks like this. And the twin is simply going to look down like this. So either ways, you are seeing that from the left, this thing is going up. So you have to write. So from the left, x approaches 2 from the left. The function goes up to positive infinity. Then if you are coming from the right, it goes down. Negative this. So meaning the limit does not exist. You just say limit does not exist. DNA. They want to see this. No wonder we're writing them. So this is what you would do if they were to ask you a case that cannot be simplified or rather manipulated. Yeah, so any questions, guys, up to this point? Is everyone okay with this?
I have a question, sir.
Yes.
Is it a must for us to draw the graph, or maybe we can? Because I tried solving, but I got 4/0.
You got 4/0. Okay, so the reason why you are getting a 4/0 is because the function does not accommodate the number that we're approaching. The number that we're approaching has to be part of the domain. Remember, for you to be able to replace directly, to satisfy what's a limit, that's what we're asking ourselves. A limit is a number that we're approaching, which is part of the domain of that particular function. And normally, when you replace that number in the function, it's supposed to give us a proper integer, right? So you're having your function as f of x is equal to 4/2 minus x. So is it possible for us to get f of 2? That's what we're simply asking. So if you put 2 there, you're going to put 2 minus 2. This gives you 4/0. That's what you got. What's the domain of this function? The domain of this function is all numbers, but x must never be equal to 2, because the down part becomes 0 when x is equal to 2. When you solve this, what makes the down part to be 0 is 2. So we're removing the 2 from the set of all real numbers. Any other number is allowed, but not what? But not 2. Yeah, so we cannot substitute with 2 directly. The function will be undefined, because remember the last statement here says the function has to be defined. If it was 0/4, it would have been okay, meaning 0 divided by any number is what? Is 0, right? Yeah, so that's the reason why we are sketching, to tell them that the function is not defined at 2 because it has a vertical asymptote at 2, and the behavior of the function as we approach 2 from both sides is different. Yeah, so if there are 2 buses from the left and from the right, they don't have a uniform station. One goes in a different direction, the other one goes in another direction. They will never meet, meaning the limit does not exist. There is no bus stop that connects the 2 roads. I don't know if that makes sense. Is that okay? Okay, so regardless, try this guy here. I've left you the last one as a task as well to check if the limit does exist. Let me add on something else. Let me add j. So j, I want you to check the limit as x approaches 3 of x squared minus, let's say what? Is it 7x then plus 12? Then down we have what? This is going to give us, okay, x minus 3. I want you to check this for me. So these, you have 3 questions now, right? This is what you have. So for those who are unregistered, you can inbox the line 0978 73 90 38 on WhatsApp. Then you'll be able to access the full solutions, of course, at a fee of just 85 kwacha per course. Yeah, so thank you so much for watching.